Good afternoon, everyone. Welcome to Monday. It's Monday today. Welcome to Monday afternoon's lecture. Today will basically be a repetition of last week's Thursday with random access files. Just to kind of get you guys into random access files, we're going to discuss things a little differently today, just to give you a slightly different approach or to give you a different idea to play around with in your mind while really considering what is a random access file and what is a sequential access file. Now, the first thing I want to cover is going back to sequential files. So sequential files is storing information sequentially, listing the objects one after the other, but keeping in mind that you're listing or storing the entire object. If you're looking at a class or at a record structure, you're storing all of the information inside that specific class. But one after the other, which means you don't need to track how much information is being stored because the application does that for you. It puts an end of data or end of type notation so it can identify where that object starts and where that object ends. So you don't have to specifically track where that object starts, ends, or where you are currently. With a sequential file, there are a few benefits and a few disadvantages, but I want to talk about the disadvantage briefly. The one disadvantage you have, and I want to ask you guys, just think about it very quickly, like 10 seconds thinking about it. If I want you to go and retrieve a specific record or a specific object, let's say you've got a list of 10 students, and I want a student that will most likely fall in the middle of your list or at the end of the list, regardless of where it falls. I want you to go and search for a specific student. How will you do that? Okay, so you have to search through all the records to find the object. You've got read all data and loop through to find using code. You have to use direct cast. Well, I mean, if you're getting it back from the file, you have to use direct cast. Going through all the records, yes. So you guys can already see we need to go through everything to find specific information, which is fine if it's just 10 people because computationally it's not that heavy. But let's say you've got 1,000 people or 100,000 people, and you have to do this for every single student you have. You have to search for the student, then you can enter the marks and then save that mark. And save it at the end. How will you know where that student is? By looping through everything. So now you're going through everything one by one to find that specific student. Do you think that's a good thing? And there's a yes and a no to that. Too slow? No, no. Waste of time and code? Okay. Now, is there anyone think that is a good thing, that is how it works? Is there anyone that would prefer using a sequential file over a random access file? You can ensure there are no doubles? Unfortunately not, because remember, you're listing one after the other. So if you have a duplicate, the file is never going to be aware of it because you'll just be storing it one after the other. So you can potentially have a duplicate there. For random access files, a duplicate is not as possible, but having a duplicate can cause issues as well, depending on how you store the information. Data stored in better format sequentially? Not really. It's just the object being stored. But we're getting off track here. So a sequential file is one after the other. A random access file is you use a specific identifier or a specific attribute, and then you use that as the identifier of where you're going to save your information. Now, it's not always ideal. If I just suddenly vanish, it's most likely the power that cut. I'm pretty sure Mr. Scott will just quickly talk while I get my backup power running, but in any case, let's hope that does not happen. Now, it was just thunder, not lightning yet. I am thoroughly protected. I'm hoping nothing will happen. Touch wood. All right, so looking at how random access files work. Random access files, if you look at how we're going to read them, needs a size allocation. You need to be aware of how much information you're storing, and that is absolutely crucial. Now, one thing that I have not done, which I said I will do, and I will do that today. Actually, not. I'll do that most likely tomorrow because I will be busy with exams today. Is to put this into a slide for you with the enum stuff. So I'll make sure to put this in a file for you. For those that are not aware of what this is the documents from Microsoft for Visual Basic specifically that dictate, or that not dictate, but that kind of shows you how many bytes a specific data type takes. So you can see a single character takes up 2 bytes, so you know that it's Unicode because of how many unsigned values there are. And the rest are not as important. The important ones are the ones that you'll be using. So it's things like string. Now, string is essentially an array of characters, so that's why I say the characters are important. You've got your doubles, and you've got your integers, and you've got Boolean up here. Now, it depends on how VB implements it, so we'll play around with that tomorrow to see what's going on there. But I would say make sure you know the sizes of the common ones, the ones you'll be using. So that's string, char, integer, and double. So that you're just aware of how much information you need to reserve when creating a random access file. Now, with a random access file, you need to dictate the structure. Now, keep in mind, your application is not going to tell you what structure or dictate how the structure file is going to be. It's you as the developer that will do that. Now, with sequential files, the structure itself is one after the other. I'll get to your question in a second. I just want to finish the slide. So the structure itself is one after the other. So it's not really system generated or system managed. It's just the fact that it's one after the other. There is no real structure except for it has a breakpoint between each object. It can understand this entire piece is a object. Other than that, there is no format in which it is being stored. There's no alphabetical format unless you control it as a developer. There's no numerical format unless you control it as a developer. And there's also no size brackets, fixed size brackets, so that you can kind of jump through it and find information. If you want to read from the file, you have to take the entire file. If you want to write a file, you still have to take the entire file, because if you don't do it properly, you're going to overwrite the things. Now, luckily, Visual Studio does have the additional options of append and concatenate, but we are not going to allow you to use them. So if you're going to read and write a file, you have to dictate and control everything from storing the entire file and then putting the entire file back with the changes. Because we want you to get used to the idea of having to control everything. We don't want you to rely on the system. Yeah, if you have lightning in your areas, maybe be safe. I mean, I'm taking a risk, but I have to lecture you, so don't have much of a choice. Right. So, random access files. You need to know the size of everything, but you need to know what the size is because of the structure you're going to use to save everything. Now, before I go with that, let's just quickly get to the question. Sir, are you saying random access files are easy to retrieve objects? I'm assuming you're saying easier to retrieve objects than sequential files, because the sequential files have to loop through all the elements to find a specific object needed? Yes, that is what I'm saying. Remember, a sequential file is listed one after the other. There's no indexing, there's no searching. If you want to find something, you have to loop through every single item in that file in order to find it. Now, If you're lucky, it's going to be at the very beginning of the file. If you're unlucky, it's going to be at the very end of the file. So, there's no average search algorithm that will tell you, okay, the quickest way to find your object is using this algorithm because then you're going to find the object faster. Well, there are searching algorithms like that, but you'll be only taught that in your third year or your second year. I think your second year. But essentially, the way it's being stored, there is no tracking. It's just dump the information. Here's one, put in the next, put in the next, put in the next. There's no real order to that. When you want to find something specific, you have to take it out again. You have to take out the first one. No, it's not what I'm looking at. Take out the second one. No, it's not what I'm looking for. So you have to keep on taking them out until you find the one that you're actually looking for. You can handle that one, but now to store it back to that specific location is also an issue because it's being stored one after the other. You can't ensure that you're replacing the correct one. So you have to take the entire file, change that information, and basically recreate the entire file. That's the you have to control everything part. And there are other ways in which you can kind of, you don't have to do it like that, but we're not going to teach you that right now because, like I said, the concept is you need to get used to the fact that you need to do everything. So you need to be aware of the things. So the other tools will kind of merge things together where you take files, you take a bit out of it, you will correct them, and then you'll merge the things back together. And we'll get to that later on. But random access files allows you to dictate the size of the data being stored. So it's blocks being reserved, essentially. And the information inside that file will also have a role in where the information is being stored. So when we look at an example of information that we want to store, so let's say we want to store student information. We've got an ID, a fixed or VB fixed string of 15 characters. So we've got a string, a surname, and an average, which is a double. Now, a few things to note here. VB fixed string means that only 15 characters will be saved, will be stored or be used. If you don't put in 15 characters, the rest of the spaces will still be filled with empty information. There's going to be information there, but it's going to be empty so that when you save surname, the system will see there are 15 characters. It doesn't mean all 15 characters will have viewable information though. So the information or the characters that are given to you, that will be viewable, but when the system uses the string, it sees it as the string represents 15 characters. There will always be 15 characters in the string. That is a very good thing, and we'll test that out. I want you guys to think about that. If I put more than 15 characters in there, will it break or will it work? Now, the easiest way to find that out is a small test program. So we can go and take input box, try and put it in a fixed VB string of 15 characters and see if it breaks or not. So we'll do that. We'll do that tomorrow in the TUT, or if I have enough time, I'll do it after this lecture. But questions like that are things that you should test out for yourself as well, because then you know what happens. It's not a conceptual thing anymore. It's now a practical thing that you've gained from experience. I've tried it. It breaks. I am now aware of what will happen. So when I get input, I need to try. If you know things are going to break based on what the user does to your system, then you know that's something you need to validate. And that's where validation becomes important. But this lecture is not about validation now. But like I said, very good question. And if there's enough time, I'll show you what happens. Otherwise, we'll definitely show you tomorrow. Now, using a random access file, like I said, you need to be aware of the sizes of the data sets that you're using, because you need to now keep track of how many bytes you'll be using. So when we look at an integer, as we said, an integer represents or is represented by 4 bytes. So if you look at our reference document, you'll see that the common language structure is N32, because that's how we're going to read it back, but it's represented by 4 bytes. You've got a string, surname, So that's essentially just an array of characters. So we've got 15 characters, which we know a character consumes 2 bytes. So that will be 30 bytes in total. And then we've got a double, which is 8 bytes. Just to show you, it's 8 bytes. And the nice thing, it also shows you the maximum size allocation here. So if you're to negative and you're positive. All right. Now, we put in information. What happens to the empty information inside bytes, seeing as Beloy is only 6 or 12 bytes in total? What happens with the other 18 bytes? Now, that other 18 bytes will be empty, but the information will be represented as null spaces, unallocated spaces, essentially, to ensure that it is correct. So the system will see the following. It will see, no, it's not the following. The system will see you've got 4 starting bytes for your integer, 30 bytes for your string, and 8 bytes for your double. Yes, it will be empty, but it will still consume memory because it's a fixed allocation. So that fixed allocation is reserved when being used. Now, saying exactly how VB handles that in memory, but because of the declaration, it will be a reserved space of that many bytes. Now, normally strings are more of a representative value, so that when you declare an instance of that type, depending on how many spaces it represents, it's stored in a sequential manner inside your RAM. But that's also things for later on. So all you have to be aware of right now is that you tell the program, this is how much information, how much space is needed to store it into a file. The actual details about how it's handled in memory is something you can detail in your 3rd year. So with sequential files, the spaces are infinite. Well, I wouldn't say infinite. There is a maximum limitation, but it's an object being stored. Keep in mind, you're storing the object. So depending on how many instance variables you have in the object or how many variables you have in the object, it will store it to that extent. But it stores it and then places a marker at the end, a marker or a flag or however you want to describe it, but it places a specific term at the end of the object to say, this is the end of the object. Your system is going to read this file until it reaches that end of object identifier and say, here is one object. And that's how it breaks them up. Now, with random access files, there is no end of object reference. There's only an end of file reference. So it will keep on reading until it reaches that end of file reference or until it crashes. But with random access files, you've got potential of open blocks. Because you're using specific identifiers to save information, it's being stored at a specific location. All right, I think someone might have had a question there. Someone unmuted themselves for a moment. Do you have a question? Okay, I'm assuming it was just by accident then. All right, so in this line, you can see that it is showing you the binary writer. So with the sequential files, you wrote the entire object to the file. So you had the binary formatter, you had the file stream, and then you just had the binary or the object that you're passing along. Now, with a random access file, you need to find the location of the stored item. In this case, the location of where you store the item. So one of your attributes Well, like I said, the binary formatter will take the entire object and store that for you. A binary writer stores a specific piece of information at a time. We can look at the exact details if you want to. We can do that during the TUTs, or rather, let's do it during a lecture, so we can do that on Wednesday afternoon. But for now, all you have to be concerned about is how it's being used. So a binary formatter takes the entire object and stores that. Now, a binary formatter can also work with individual objects. It can work with a string, it can work with a char, it can work with a... So there's no difference there, but a binary formatter, after storing the object, adds an end of object reference. So that when you read the file again, using the deserialize part of the binary formatter, it takes the object itself and then you have to put it into a format. So instead of having multiple random objects, you basically have a structured, well, if I say structure, it's data structure of an entire object, and you take the entire object and put it back into that data structure. Whereas with random access files, you're storing the items one by one, but you are saying that you're storing the ID, you're storing the surname, you're storing the average. So you have to store each element of the object on your own and not rely on the system to do it for you. The beauty of this is because of the attribute you'll be using to store the information, and most of the times it's a unique attribute to that specific file, like a student ID, or a student number, or a person's ID, an employee number, anything that will uniquely identify this record itself will be used as the location. So you take that piece of information, you multiply that by the total size allocation of what you're storing, or the maximum size allocation of what is being allowed to store. So in this case, for our student, we know the structure is ID, surname, average. And because of our fixed VB string, we know that this is going to be 4 bytes, 30 bytes, 8 bytes, which comes up to a total of 42 bytes if everything is being consumed or used. So we take the identifying attribute, multiply that with the total amount of bytes that are being expected, or the maximum amount of bytes being expected, and then we search for this spot from the beginning of our file. So seek origin dictates where it's going to begin searching. So seek origin begin means that it's beginning from the very beginning of the file, from byte 0. Seek current looks at the current position in the file itself. So that's if you're already working with a file, if you've previously stored something, it will look at that specific location. And then seek end is at the very end of the file, which has its own benefits, but we're not going to go into too much detail there. Once you've found the location where you want to store the student, you then start by storing the information of that student individually. So you've got your ID, your surname, and your average. Then once you've stored that information, you close the file stream. So you store the items individually instead of just passing the entire object over into the file. But the beauty is that you can now go and search for that item. So if you want to find a student, so instead of having to read everything out, you can go and find that student by giving it an ID, searching from the beginning of the file, and then it will jump to that location and read that specific information for you. Then you can read that information. So you can start by reading your integer back, your ID. You can read your string back, your surname, and you can read your double back, your average. It allows you to search for that. So instead of having to go through a for loop to find a specific student, you can now just search for that student via its ID itself. Now, before I continue there, who can tell me what is the difference between a record structure and a class? Okay. Kind of walked into that one. The name, obviously, record structure and a class. A class is like a blueprint for a record structure. All right, so you've been working with classes for a while now, and here's an example of a record structure. Record structure contains data, and a class has the functions implemented inside the class. Class has private, record has public. A class is also public. What's the main difference between the two that you are aware of? Let's forget about the theory behind record structures and classes for a second. In your experience, because you've used both now, what's the difference between a structure, a record structure, and a class? Yeah, but having the property methods will still make them public, so you still have access to them. I want the main difference. What is in one and not in the other? What sets them apart? Record structures are in the form, classes are declared in the form. Yeah, but there's still a difference. Record structures occurs within a class. Well, a record structure is within a class. Your form load or your form is a class essentially. Structure is for composition. You guys are overthinking this. What is in a class and not in a record structure? There we go. A class has methods. A class has property methods. It has constructors. It has utility methods or any function that you can think of or want for that specific class. A record structure is simply just that. It's a record. It's just for the data. Now, let me ask you this. Can you replace a record structure by just using a class? Yes. So all you're referring to is essentially a class with no property methods, and no functions. Can you replace a class with a record structure? No, because a record structure doesn't have any functionality. It is only data. I'm using a record structure to demonstrate random access files, but I just want you guys to be aware of the fact that our structure itself, it just represents the data of a class. We're not interested in the functions here. We're only interested in the data. So you can apply this to a class as well, making sure that they are in the correct format though, because you'll most likely be using the property methods if you want to retrieve the information, making sure you've got the correct information or the fixed size information in any case. But the idea here is to show you that with a record structure, we're interested in the data, the individual data here specifically now. Random access files stores information individually, with you dictating where the beginning of that record is being stored. With sequential files, we don't care about the beginning. We just tell it, here's an object, store the object. And with a sequential file, it always begins at the beginning. So if you don't accidentally track where you're putting the information, it's going to start overriding from the start. But with a record structure, it stores the information from the ID, from that position that you determine with the ID. But this ID can be anything that's unique to the student. So some places uses username, some places uses email addresses. Anything that is unique that will allow you to identify a specific record can be used. And that is what's important with record structures, is having that attribute, that identifier. Now, I'm not going to go into too much detail about how to set up a decent identifier identifier, because we'll be covering that in detail next year. But just be aware of the fact that when you use information, it needs to be something that sets this information apart from the others. Now, what if you have an array inside your class? Can you still use a record structure? We've got a yes and a no, and I'll get back to that. I missed a question here. So can we use a record structure and have methods in the structure like C++? Can you be more specific there? What do you mean have a structure? Just keep in mind, we've got a record structure, which is just the data. Then we've got our interfaces and our inheritance. Our interfaces has the abstract information for us, and then a class has our functions for us. And if our implement interface dictates it, then it will have a must implement interface or must implement functions. A record structure in this case is pure data. There's a reason why it's being called a record structure. So the record structure itself is supposed to be a structure of information and not functionality. Specifically, when we start moving over to databases, where when you start talking about a record, you're talking about a row of information that is represented in your database. Okay. But you will understand the ID thing a bit better once we talk about hash functions, and that's still coming. We'll talk about that on, let's see, we'll probably talk about that on Thursday. Otherwise, we'll just swap Wednesday and Thursday around, and then we'll discuss it on Wednesday. All right. So, once again, just the important note to take away from record structure is the fact that you need to find that information. You need to know where that information is done. Can we use a binary writer to search a sequential file? I'm assuming you just understood the problem there. Is the fact that you need to point to where the beginning of that object is. And with a sequential file, you don't know where to find that pointer. If you can find that pointer and read the file itself, then yes. But we haven't shown you how to do that. It is possible to do that, but not with the way we're showing you right now. So this way, you know what the data type or the data sizes are, so you can go and search for specific brackets, and you're basically looking at the beginning of the bracket. But the ID number, you're kind of using the ID number as your hash value, and we'll talk about that when we get to hash files or to hashes. We'll be talking about that briefly, or we'll be using it tomorrow, but we'll show you tomorrow what a hash file is. Ms. Gottschall just said we'll show you tomorrow, but essentially we'll do a lecture on hash, so you kind of understand the function of what's going on. But the idea here is that you use a piece of information from your structure to identify where you can store it and save it, knowing the structure size. If you don't know the structure size, you don't know where to begin, because you can just land up at any random location and you don't know whether it's the correct starting point. So how will we know how many number of bytes we need to multiply with? That is the maximum structure size, as I said in the beginning. So if we look at our structure, we've got an ID, a fixed VB string, which limits it to 15 characters, and we've got a average. So we know it's 4 bytes, 30 bytes because we know it's 15 characters, and then 8 bytes for our double. Now, if you have a class, you need to dictate how large this class is, because you know your instance variables, you know how much data it will consume, aside from the strings themselves. But if you want to store them, you need to set a maximum size so that you know that you have enough space for it. Like I said, if you're storing something like a name, you need to consider what the maximum length of the name will be, so that you can say you'll be storing 50 characters or 100 characters, however long the name is. So you need to know what the sizes are. Then you add up the total amount of space being consumed by each one of these variables for your structure, and that is the multiplying value. Because if you look at it, you've got 4 bytes for your string, 4 bytes for your integer, a total of 30 bytes for your string, and 8 bytes for your double. Now, keep in mind, it stores 30 bytes. When you save this, it's going to reserve 30 bytes. It's not going to consume all 30 of them, but it's going to store them. Empty spaces, remember? Then you separate the information individually, you find the location you want to store them at, and then you just store them. But the thing is, that location, that multiplier, is the maximum allocation or the maximum size of the record. So if you filled all 4 bytes for, oh, well, you will fill all 4 bytes for the integer, but if you filled all 30 bytes for your string, and then the total size of this record will be 42 bytes. Whereas if you're just storing Beloy, your total size of this structure itself is, okay, so that would be 12, 20, 24. Because the rest of it is empty information. It's reserved in the file, but it's still empty information. It's nothing but something as well. All right, then another, what if you don't have a fixed value, a dynamic array? Well, the problem with a record structure is, or with a random access files, you need to know how much information is being stored. There is a maximum and there is a minimum, but you need to be aware of the maximum. Same with a database. A database is, there is no dynamic database allocation. It's a pre-planned, pre-structured structure that gets developed. Dynamic things are handled in separate ways, which we're not going to discuss in too much detail there because that's more second-year database stuff. But a dynamic array is a set of information. So inside your structure, a dynamic array is not going to be that good. You need to be aware of how much information you're storing. But you can store a dynamic array of objects. So let's say you're storing a dynamic array of students. Your student structure itself is set. You know how much each student is worth in terms of bytes. When equating variables, does it matter as to which one I start with? If you're checking whether life is equal to green or green is equal to life, but just keep in mind, if you're checking, it's generally 2 equal signs and not just 1. I'm assuming that's what you're getting to. Assignment is 1 equal sign, and then a comparison is 2 equal signs. Is that what you're asking? You can talk.
Okay. Hello. Good afternoon, sir.
I can hear you. Good afternoon. Okay, now I can't hear you. Are you talking?
Okay, what I meant is that during in two of my practicals, right, Okay. In one of my practical, I said value is equals to, for example, let me give an example with last week's practical. I said value is equals to underscore kilometer. I got a 0, but when I said underscore kilometer, number that the user entered.
You broke slightly there. So what I got from that is when you said value equals underscore meter, you didn't get a mark for it. But how did you use it? Were you assigning a value to the instance variable, or were you assigning a value to, well, the value variable?
Okay, basically what I said, it was in the property method, right? I said I said value is equals to underscore kilometer. When I tested that, it gave me a 0. Every time it gave me a 0. But I said underscore kilometer is equals to value. That's what the actual value that the user entered in their form.
Yeah,
So
but that's assignment. If you're assigning something, your storage variable, if I can say the storage variable, if you're assigning whatever you're assigning to is on the left hand side, and the value you're assigning to that is on the right hand side. Assignment always works to the left. So it is value you want equals to value you want to store. And you're getting a 0 because your integer or your underscore meters is of type integer, and a null reference in an integer is a 0. He is not here anymore. He disconnected, it seems. You just check. No, he disconnected. He's reconnecting now. Okay. Okay, you're back. So I don't know how much you heard. I think the best way to look at it is just send me your student number via Discord or email, preferably via email, and then I'll explain to you why that happens. It's just based on the rules of assignment. So assignment always works to the left. And he disconnected again. That's Blackboard for you. All right. Okay, but that is it for today, ladies and gentlemen. Unfortunately, I can't stick around for too much longer after the class today. We'll do that again tomorrow during the tutorials. So please do come to the tutorials tomorrow. We're going to be discussing random access files. We will be looking at hash functions. I'm assuming, what line of code does it find the data in the file when reading? Oh, so on line 4 over here, it's when you're seeking the information. So the ID is the ID being passed by the user. You're using that as your identifier, so you're multiplying that by your bytes, and then you are seeking from the beginning of the file, you're searching for that specific information. Now, there's a different term to indicate this. I haven't discussed hashes with you yet, so I don't want to discuss that term yet until we've discussed what a hash is and how we use a hash function, because that basically explains this part is a hash function and a hash value. So we've got a hash function, and the result is a hash value, and that hash value is where information is being stored. We'll discuss that in a lecture with hashes. Was it your validate method that was returning 0? Okay, well, that is he left now, so he won't be able to answer that. But from the sounds of it, it was an assignment issue. It just seems like he assigned to the wrong side. Okay, ladies and gentlemen, like I said, that is it for today. If you're listening to the recording, please make sure you watch the tutorials. We've noticed that there's been a reduction in the amount of students watching the tutorials, which is a bit concerning for us, because files will be the main focus of the second semester test. And for the exams, you will theoretically be asked about files as well. So please make sure that you do attend the tutorials, at least one of the Tuesday tutorials. And then in the lectures, we'll say whether the Thursday tutorial is that important or not. But please make sure you attend at least one of the two, or watch at least one of the two Tuesday tutorials. Mr. Gottschall generally covers an entire practical, whereas I intentionally break code so that we can see what happens, especially with the questions that you have during the lecture of what happens if you do the following, what happens if you exceed it, what happens if you don't give it enough. I intentionally go and break the code so that you can see what happens, so that you're aware of the issues that can occur and how to fix them. But tomorrow might be different. Tomorrow will be most likely be a duplicate of a random access implementation of a file. Right. Other than that, I'll see you guys tomorrow during the tutorial. Please be safe. Don't risk it with the lightning. I'm pretty sure you guys don't want to lose your hardware now. I have a question about the group prac. How are we going to use DLLs? Will we cover it this week? Now, DLLs are covered next week. I can release the slides early if you want to. DLLs are only listed for next week. It's given as an example. Some of those elements are more dedication to see who will actually go and read ahead of time, because you've got the learning guide and you know kind of what we're going to do. So 2 of the things in that rubric is things you haven't covered yet, just to see who will actually go ahead and see what they are. So what I can do is I can release the DLLs early, but it's not going to be covered before the project is due. It's fine, it's bonus marks, yes. Okay. All right, so I will just remind me in the tomorrow or on Wednesday to release those slides, because I most likely will forget to release them. Other than that, guys, I'll see you tomorrow. Otherwise, I'll see you on Wednesday's lecture, and I will stop the recording as soon as my screen is not blank anymore. So right now, I can't see anything. I'm assuming you can still hear me.